Hello everyone, my name is Naveen Kumar, Faculty of Physics at Rawat Public School. I hope everyone is fit and fine. Now, today we will discuss about the chapter number 2, electrostatics, potential and capacitance. The topic is capacitance of parallel plate capacitor with a conducting slab inside it. Okay, now consider a parallel plate capacitor. Okay, the area of these plates is A and the charge on these plates is plus minus Q. Okay, one plate is having plus charge and second plate is having minus charge. Okay, now separation between these two plates is small d. Okay, now we have inserted a conducting slab inside the plates of this capacitor. Now because of these charges, a electric field develop inside the vacuum space in this capacitor, and inside that conducting plate electric field is zero because free electrons will reduce the electric field to zero. They will produce inside that conducting slab and electric field will reduce to zero. Now when we are having this capacitor, then the capacity of that capacitor when vacuum was inside its plates without that conducting slab, the formula is C0 is equals to E0 A divided by B. This is the capacity of this capacitance when there is no conducting material inside its plate. Okay, now our electric field will develop inside the capacitor, that is E0, which is equals to sigma divided by epsilon naught, where this sigma is surface charge density. Formula for this sigma is sigma is equals to Q divided by A, that is Q is charge over the plates of this capacitor, A is area of the plates. Okay, now substituting the value of this sigma, we will got Q divided by A epsilon naught. This is electric field inside the plates of this capacitor. Okay, now there will be a potential of this capacitor, that is this electric field. The potential is equals to, we know the formula that potential is V is equals to EB, but when we insert a conducting slab inside the plates of this capacitor, then that electric field is for this region only, that is this vacuum space and this vacuum space. Okay, so electric field is reduced in this region only, D minus T. So potential will develop inside that area, that is E0 D minus T. This will be the potential inside that capacitor plates. Okay, now on substituting the value of E0, this is V0 is equals to Q divided by A epsilon naught, that is D minus T. This is the potential inside this capacitor. Okay, so when we inserted a conducting slab inside the plates of this capacitor, then what will happen? That capacitor is having a different capacity. Okay, so how we are calculating capacity? Well, the formula for capacity is C is equals to Q divided by V. This V is this one. Substituting the value of V in this equation, C is equals to, that is Q divided by Q D minus T, and this is A epsilon naught. Now Q cancel out, so this is E0 A divided by D minus T. Okay, so this equation will become like this: E naught E, take out D common, then it will appear in both numerator and denominator, that is D. Now this E naught A divided by what we are writing here, it is C naught is equals to E naught A divided by D. That means we can write down E naught A divided by D as C naught. Okay, so formula will become like this: C naught B divided by D minus T. That means we can say that capacity of the parallel plate capacitor, when we insert a conducting slab inside its plate, then the capacity is C naught B divided by D minus T. By looking at on this equation, we can make a conclusion that capacity of the capacitor, when we are inserting a conducting slab inside it, then the capacity gets increased by the factor D divided by D minus T. That means capacity of the capacitor is always greater than initial capacity. That is, final capacity has increased by this factor D divided by D minus T. Now, our next topic is capacitance of parallel plate capacitor with a dielectric slab inside it. Now, we have replaced that conducting slab with a dielectric slab. Okay, now what is that dielectric? Basically, a dielectric is a material which does not allow flow of charges, but it allows the charges to exert force on one another. Okay, so essentially the dielectric basically is an insulator, okay, which can be polarized by applying electric field. But this dielectric is placed right now inside a conductor, and that is capacitor. Okay, the thickness of that dielectric slab is T, and the separation between the capacitor, parallel plate capacitor plates is D. Okay, now when there is no dielectric slab inside that capacitor, then the capacity of that capacitor is C naught is equals to E naught A divided by D. Okay, now similarly, as we did in the previous derivation, electric field get developed inside that plates of the capacitor, which is equals to sigma divided by epsilon naught. This sigma is obviously a surface charge density, so we can write it as Q divided by A epsilon naught. Make it a difference between the electric field, that is E naught and epsilon naught. Okay. Now, when a dielectric slab of thickness T is placed inside the plates of this capacitor, then this obviously T is less than D, that is the separation between the plates of the capacitor. Then a electric field get developed inside that dielectric. Okay, electric field in this vacuum space is E naught, and there is an electric field which is in the opposite direction is developed inside the dielectric, that is EP. This EP is sigma P divided by epsilon naught. The electric field which is developed inside the dielectric slab, that is E naught minus EP. Total electric field in this arrangement is E naught minus EP. EP is in opposite direction and E naught is in this vacuum space. Obviously, this thickness of the slab, dielectric slab, is T. Okay, so electric field in this capacitor, when we insert a dielectric slab of thickness T, is E is equals to E naught minus EP. So we can write down E is equals to E naught minus EP, or simply this is E naught minus E naught divided by K. Now a potential get developed in this arrangement. Okay, the potential is in this region, and this region. Okay, so total potential is E naught, which is in D minus T region, plus E P. That is electric field in this region and thickness of that plate. Okay, now we can substitute this E as E naught by K. So it is E naught D minus T plus E naught divided by K T. Take out E naught as common. So E naught common, so this is D minus T and plus T divided by K. Okay, now capacity of the parallel plate capacitor is C naught is equals to formula is Q divided by V. Substituting the value of V, so this is Q divided by, substitute value of E naught as well, so this is Q divided by A epsilon naught, this is D minus T plus T divided by K. Q cancel out, so it is E naught A divided by D minus T plus T divided by K. So this is the capacity of parallel plate capacitor when we insert a conducting slab inside it. Thank you.